recording. Okay. So we know how to do gram to mole conversions. If you're presented with, well, mole to gram, how different is that? Not very different. It's still one step. And there were a couple of these on the front page. So let's say I tell you that I'm handing you a lump of 7.26 moles of iron. And I would like to know how many grams of iron that is. What do you start with? Factor label, what do you always start with? Given. 7.26 moles Fe. What goes down below to cancel? Always. Same unit, same chemical. Moles of iron. What goes above? The thing we want to end up in? Grams of iron. Where do we get that relationship? The periodic table! So, 1 in front of moles, 55.85 in front of grams. All right, wunderbar. Give me a raw number. Okay, so we have 405.471 grams. As a raw answer, 405 grams of iron as a final answer. And this is just flipping the gram to mole on its head. With grams to moles, the only numbers that are ever going to go into your conversions are 1 and the molar mass. Okay? That's it. That's really fairly important. So now let's go to the other end of the GMA thing. And let's go atoms to moles and moles to atoms. Okay? These are still one-steppers. So if I am told that I have 4.73 moles of carbon, and just because I'm a crazy weirdo, I want to know how many atoms of carbon that is. Is there a conversion factor that will get me from moles to atoms? How many pieces in a mole? All together now, 6.022 times 10 to the 23rd. Yeah, that number, Avogadro's number. So what do we start with in any factor label? Our given, always. So we start with 4.73 moles of carbon. What units and what chemical go down below to cancel? Moles, carbon. What units, what chemical go on top to end up in? Atoms, carbon. Do you know why most people like these kind of problems? They are stinking predictable. And I will give you the gospel of factor label. Many, many years ago, I had a young man, awesome young man. I'm not sure what he's doing right now. I think, anyway, I was saying again and again, if you set the factor labels up, if you label everything, the problems pretty much do themselves. If you check your units, because we're going to get to ones of these that are 3 and 4 steps long, that are not single-step problems. But if you pay attention to the units and you set them up well, the problems do themselves. And after I had said this for like the 6th time, this young man from the back went, "Amen!" Yes! This is the gospel of factor label. If you set these up well, they do themselves. They just walk right through and you get an answer. Okay, so let's double check. Will moles of carbon cancel? Yes, they will. Will we end up in atoms of carbon? Yes, we will, and that's where we want to be. Now, the larger question, what numbers do we put in here? And where are we getting those numbers? So, here's the thing. When you're doing conversion factors and you have moles of carbon or moles of iron or moles of dirty socks, moles of stinky 10-year-olds, there's only one number that's ever going to go in front of moles, and that's 1. 1 mole of carbon atoms is how many carbon atoms? How many donuts in a dozen? 12. How many pieces in a mole? 6.022 times 10 to the 23rd atoms of carbon in 1 mole of carbon. So, what do we get for a raw answer? Well, let's set this up, because this is one of those places where people do sometimes trip on their feet. 4.73 times 6.022 divided by 1. I'm going to shrink this a little bit. And that whole mess times 10 to the 23rd. So I have to do a little bit of work to get my answer here. Okay, so I've got 28.48406 times 10 to the 23rd atoms of carbon. Is that an answer that I can leave? No. What do I have to do? I got to fix the scientific notation, because I can only have one digit in front of the decimal. So I'm going to do my stupid little human trick. Okay, so coming back the other way, that's going to move, and we're going one more, so that's going to be 2.848 blah 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 times 10 to the 24th. How many sig figs can I have? 3. I can have 3 sig figs. And so what that means, and everything that I put in scientific notation is significant, so I'm going to have 2.85 times 10 to the 24th atoms of carbon. Okay? 2.85 times 10 to the 24th atoms of carbon. That's moles to atoms. What about atoms to moles? Did you get a different number? Oh, okay.
No, it's like on the calculator.
Let's turn it on its head. I'm going to copy this, go to here, paste this. Now we're going to do atoms to moles. All right, let's say I am told that I am given 7.2 times 10 to the 22nd atoms of aluminum. What the heck? Atoms of aluminum. I want to know how many moles that is. I want to know how many moles that is. What do I start my factor label with? Always, always, always. Given. 7.2 times 10 to the 22nd atoms aluminum. What units and what chemical go down below to cancel? Atoms of aluminum. What units and what chemical are going to go on the top to end up in? Moles of aluminum. Okay, what number is going to go in front of moles? Always, always, always as a conversion factor, 1. What number? How many atoms of aluminum in 1 mole of aluminum? 6.022 times 10 to the 23rd. We could like sing it in harmony. 6.022 times 10 to the 23rd. Okay, when we look at what we're actually doing, we are actually taking 7.2 divided by 6.022 all times 10 to the 22 minus 23. Okay, so our raw answer, 1.19561 blah 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 times 10 to the negative 1. We don't have to move any decimals on that. We're in correct form. But we do have to get it down to how many sig figs? How many sig figs? Becca, 2. So we're going to keep this. So what does this become? 1.2 times 10 to the negative 1 moles of aluminum. So, you know, basically 0.12 moles of aluminum. Pretty small amount. Okay. Questions, comments, concerns on the one-steppers? What I'd like you to do right now is go through and pick out a couple more of the one-steppers. I'm going to show you a little trick that I sometimes do. I mean, I can, good Lord, I have a minor in chemistry. I've been teaching chemistry for, this is my 9th run through chemistry. I could do these in my sleep. But honestly, even as I'm starting to do these every year, as my brain is kind of warming up to the idea, and I'm like, oh yeah, that's it. Ah, yeah, there we go. I do this for myself. Let me show you my little cheat. You see this? Before I even start to set up the problem, just, you know, and I probably won't even do this the next time I do a key, but just the first time as I'm making sure my brain's in gear on these, I make a little note to myself, grams to moles, grams to moles, grams to moles to atoms, atoms to moles to grams, moles to grams. And that just helps me make sure that I know what I'm looking for. And if you struggle with reading the problem, if you struggle with what am I looking for, that's a good little helper step for you. Can you see it? Is that better? So I just do that off to the side for myself, and sometimes that's useful. What I'd like you to do is go through and find some atom to mole, mole to atom problems, and I want you to do those. And then we're going to do two-steppers. Okay, so now we're going to talk about two-step processes. So if you are given something like this, 372.4 grams of iron, and you want to know, well, how many, I'm just curious, how many atoms of iron is that? You have to go from grams to moles and from moles to atoms. You cannot ever go straight from grams to atoms. You can't do it. You always have to go through moles. So what do we put in our first box? Always, always, always in a factor label. Given 372.4 grams Fe. Now, I'm telling you that we're going to have this many boxes. What's going to go down below to cancel? Yeah, go ahead. Same unit, same chemical. So this will be grams of iron, which makes those cancel. What do we have to go through always? The value of the moles. Always. So we're going to have moles Fe here. What units and what chemical will go here to cancel? Moles Fe. And what chemical do we want to end up in? What units and chemical? Atoms Fe. I'm gonna say it again, and I'm thinking of the dear young man shouting amen in the back. If you set these up right, if you pay attention to units and chemical, they solve themselves. Can I get an amen? No, don't really, because it just kind of weirds me out. But anyway, what number is going to go in front of moles, Madison? 1. Yep, you said you were mouthing the right answer. I saw that. Where are we going to get the number to go in front of grams? Alec, where are we going to get that? What's that thing called?
I'm not going to lie, I just started writing this down. I was working on that.
Okay. Where are we going to get it at? Periodic table. How many grams of iron in 1 mole of iron? 55.85. Okay. What number is going to go in front of moles in that last space? 1. How many atoms of iron in 1 mole of iron? 6.022 times 10 to the 23rd. 6.022 times 10 to the 23rd. So we'll check our cancellations here. Yep, sure enough. We end up in atoms of iron, which is where we want to be. I'm going to shrink all this so that we can put in a raw answer. So this is equal to, let's get a raw number. Okay, so I do like showing the setup there that we're doing 372.4 times 1 times 6.022, all divided by 55.85. So I get a raw answer of 7.80649, blah, blah, blah. I don't have to move decimals, which is always welcome news. How many sig figs do I get? 1, 2, 3, 4. I get 4 sig figs here. 1, 2, 3, 4. So I can go out to here. Final answer, 7.806 times 10 to the 23rd atoms of iron. Yes, ma'am. Oh, I screwed something up? Oh, I see why. I see why. Hold on, I screwed up. My calculator wasn't awake, and instead of 372, it didn't take the 3, so it's just 72.4. That'll give you a different number. See, I'd like to say that I just make mistakes to keep you on your toes, but that would be a lie. Okay, 372. Clear. 372.4 times 1 times 6.022. Oh, this is going to be a whole different order of magnitude, isn't it? 55.85. Okay, 40.15. Does that sound better? Oh, I'm so glad. I'm so glad. Now, I'm not glad because it means I have to move decimals, and I passionately hate doing that. But I get a raw answer of 40.15385, blah, 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 times 10 to the 23rd. I'm going to do my stupid little third grade trick and imagine that I'm going blah, 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 blah. So I'm coming back one more, which means I get 4.015 times 10 to the 24th atoms of iron. Okay, is that better? Okay. Do you want to do one that is atoms to grams together? Or do you want me to cut you loose on that? Atoms to grams together. Okay. So let's say, I'll put GMA up here. We're going to go atoms to moles, moles to grams. Let's say somebody tells you that they are going to give you, for a limited time, 8.92 times 10 to the 24th atoms of aluminum. And they would like to know how many grams of aluminum we're talking about. Okay. What goes in the first box of our factor label? Always, always, always. The given. 8.92 times 10 to the 24th atoms aluminum. Okay. What units and chemical are going to go in the next box on the bottom to cancel? Atoms of aluminum. What units and chemical are going to go above that to get us through the valley? Moles of aluminum. Always. What units? Oh, I kind of like that thing I was doing with the 3 different colors. I don't know if you like that or not, but. What units and chemical are going to go in the bottom on the last one? Moles of aluminum. What units and chemical do I want to end up in? And so we're going to go in the top. Grams of aluminum. Awesome. So I'm going to check my cancellations. Yes, atoms cancel. Moles cancel. I end up in grams of aluminum. That's where I want to be. Okay. What number is going to go in front of moles as a conversion factor? And you know what? I'm going to go ahead and plug in the 1, because as long as moles is part of a conversion factor, the only number that ever goes in front of moles is 1. You would be shocked at how many times people make a mistake with that, and they put another number in there that starts with a 6 and ends with the times 10 to the 23rd, which shall remain nameless. Okay, it won't really remain nameless. It's Avogadro's number. Okay. What number is going to go in front of atoms of aluminum? You got it, ma'am. 6.022 times 10 to the 23rd atoms of aluminum. And where are we going to get the information for the mass of aluminum that's in 1 mole? 1 mole of aluminum is equal to how many grams of aluminum? 26 point what? 98. Yes, ma'am. Okay, so I'm going to shrink this. Okay, so we're going to get a raw number. Okay, so I've got 39.9637 blah, 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 times 10 to the 1st. Well, I can do one of 2 things with that. Ooh, this is excellent. Okay, so I can put this in scientific notation, or I can just go ahead and move the decimal to here and skip the scientific notation. What's the tricky part about this one? How many sig figs do I get? 3, which means I'm keeping this place and I'm rounding it based on that place. What's going to happen here? I take that back. You can't skip the scientific notation. It's going to be 4.00. 4.00 times 10 to the second. And that is grams of aluminum. You could say 400 with a decimal behind it, grams of aluminum. You will sometimes see that. I never see it in physics. I do see it in chemistry. I don't know if there's just a disagreement between chemists and physicists. But that has to have 3 sig figs, and that 9 is going to round up, which is going to make the next 9 round up, which is going to make the first number round up. Those are the ones everybody hates. Okay, I want you working on these. Here's the one thing I'm going to leave you with before I totally cut you loose. And I'll have the key up in a second. This is foundational. This is one of those things where if you don't build this skill, if you don't learn to set these up well, you will drown later. This is foundational. So, you know, like if you never ever really master sig figs, I'm going to growl at you. I'm going to take off a point here and there. If you get to physics, I'm going to, you know, write SF all over your papers. But if you don't get this, you will not survive stoichiometry and all kinds of other stuff that comes later in chemistry. This is a foundational skill in chemistry. So we are going to spend some time on this. There will be a FIP quiz tomorrow on all the GMA conversions, all the mole math conversions. So now you're working, and I'm floating around with the key.